Hey guys, Mr. Bowman here. Today's learning objective, wrapping up our focus on distributions, is we are learning to identify a random discrete variable, and we are learning to calculate the probability of given events using some methodologies. So what we're going to do is we're going to start off with just recapping. So we learned about triangular distributions, rectangular distributions, normal distributions. We also looked about binomial distribution and percent. And what we're looking at is, I suppose we're focusing on variables that are random and discrete. So the first issue is all of these models here that we would like to use, well, they rely on an assumption of continuous data. And this isn't a random discrete variable, isn't continuous. We can get around that through a continuity correction on the here occasion. And the other thing to note is our two models, binomial and percent distributions, they only apply to discrete variables in certain contexts. So when you're trying to analyze random discrete variables, there's not a lot of choice for you to use. It might not actually fit into any of the major models that we've looked at. So there's kind of a catch-all study or a catch-all area of statistics, which just lets us to analyze any random discrete variable and come up with some probability, means, and standard deviations coming from those variables. So what I've got in the center of our screen, the two white boxes, we've got two examples of random discrete variables. So the first one up the top, that is actual data from a surprise quiz that I gave my year 9 class last week. And you can see out of 10, they've got varying degrees between 2 and 6. From that table, we can actually calculate the probability of each of these outcomes, and we can use that to make some further calculations. Just like that on the histogram, this is a random one I stole from the internet. We've got the frequencies. So here we can see, well, there were 4 people in that group, 2 people, 2 people, 1 people, 1 people. We can use all that information to find the probability of each of the bars, and then we can use that information to make further calculations. So for the rest of the video, we're actually going to focus on the table up the top, but the same approach can apply to the table down the bottom. So the first step for this question, so probability of the scores of the year 9s, is to go through and actually calculate that probability. And the probability, as always, is calculated at F over T approach. So you need to figure out how many people were in that year 9 class, or how many people sat that test, and there is 20 of those. And you'll be able to calculate the probability by going 2 divided by 20, 3 divided by 20, or however many people got that score. So the first one, what's the probability of someone getting 6? Well, that's 2 out of 20, and that there is 0.1. 7 out of 10, well, that would be 0.15, because that's 3 over 20. 8, that would be 0.35, because 7 over 20, that is the same, 7 over 20, and the last one, 1 over 20, 0.05. And if you add all of these up together, you'll find they sum to 1, because that is every single possible outcome. So from the frequency, or the frequency table, we're able to determine the probability of each of the outcomes. From this probability that we have, we can then actually use that to make or calculate the probability of certain questions. So let's change the pen color. We'll go into green. So question 1, well, what is the probability that someone got exactly 8? So this is an exact question, just like binomial and percent distributions. Well, for us, probability of getting exactly 8, that was 7 out of the 20 students, which we've already figured out to be 0.35. So that's a straightforward one. We can also use that to make more sophisticated decisions. Well, what's the probability of someone getting less than 7? So just like the other ones, we need to figure out, does less than 7 include 7? So you could have got 6, 7, 8, 9, or 10. So less than 7 would only be 6. So that's another way of saying what is the probability of getting 6, which in our case, 0.1. And the final question I want us to go through, more complicated one, question 3. Well, what's the probability of getting 7 or more in that test? 7 or more. So we'll need to do our number line 6, 7, 8, 9, and 10. So 7 or more would include 7, 8, 9, and 10. So what we need to do is we need to add up the probability of each of those groups. So the probability of 7 plus the probability of 8 plus the probability of 9 plus the probability of 10. So that's 0.15 plus 0.35 plus 0.35 plus 0.05. And when we do all that, that comes up to 0.9. So from the table, we were able to calculate the probability of given events based on that score. And just to note, we can also do the same off the table where we read and get the frequencies from how high the bars are in the histogram. So hopefully you found this video useful. The next video is going to look at how to calculate the mean and the standard deviation of a random discrete variable. So looking at that, how do we know what the average is? Well, we'll be able to calculate that. And how do we know what the standard deviation is? We'll be able to calculate that as well. Okay, now let's get into heaps of questions.